14. A liter of water contains about 3.35 times 10 to the 25 molecules. A certain river discharges about 2.3 times 10 to the 7th liters of water every second. About how many molecules does the river discharge every minute? Write your answer in scientific notation. So let's take a look at it. So the first thing I notice is that it's asking me how many molecules does the river discharge every minute. And I notice that the river discharges a certain amount of liters every second. So I need to convert seconds to minutes. So we know that there are 60 seconds in a minute. So to find out, so this is just 1 second. To find out every minute, I need to multiply this by 60 to find out that. So multiply 2.3 times 10 to the 7th by 60. So I multiply 60 times 2.3 and I get 138 times 10 to the 7th. Now to find out how many molecules is discharged every minute, I got to multiply this number by 2.35 times 10 to the 25. So I multiply these together. So I'm going to multiply the numbers in front together and I'll get 462.3. Multiply the tens to the exponents together. So 10 to the 7 times 10 to the 25 will give me 10 to the 32. You add your exponents. So now I got to put this in scientific notation. I need to move the decimal place to the left 2 places. So I'll have 4.623 times 10. Now when I go to the left, I have to add to the exponent. So I go left 2, I got to add 2. So I'll have 10 to the 34. So now the answer wants me to round to the nearest hundredth. So that's right here. I look at the 3 and see this would just be 4.62 times 10 to the 34. So let's put that. So we have 4.62 times 10 to the 24. Oh no, sorry, that is 34. And that's our answer for number 14. Number 15, it wants you to simplify the expression and write the answer in scientific notation. So let's do that. First thing we do is we multiply the numbers in front to each other. So let's highlight them. We have 0.4 times 2, which will give you 0.8. Then what we do is we multiply the tens to the exponents together. So we have 10 to the 5 times 10 to the negative 16 will give you 10 to the negative 11. Okay, so now we got to put this into scientific notation. So to put this in scientific notation, we got to move the decimal place to the right 1 place. So we'll just get 8. So when we move the decimal place to the right, we got to subtract from the exponent. So going to the left means we add to the exponent. Going to the right means we subtract. So I'm going to subtract 1 from the exponent because I only moved to the right 1. So negative 11 minus 1 will give me negative 12. So then my answer would be 8 times 10 to the negative 12. So let's put that in MathXL. So I'll have 8 times 10 to the negative 12. And that's my answer for number 15. Okay, number 16. It is asking me to simplify the expression. I have 1 over a to the 4 times a to the negative 6. So let's take a closer look at that. So first thing I notice is that I have 2 variables with the same exponent down at the bottom. So I'm going to want to simplify them first. So since they're being multiplied, I can add the exponent. So 4 plus negative 6 gives me negative 2. Now our exponent is down at the bottom. I have to make the exponent positive, and to do that, I have to move it up top. So I'll have a to the positive 2 as my answer. So type in a to the positive 2. That's my answer for number 16. Alright, number 17, it is asking you to simplify the expression. We have u plus 2 to the 8 and u plus 2 to the negative 6. So let's take a closer look at that. So our bases are going to be u plus 2. Since they're both the same, so we know our rule says when the bases are the same, we add the exponent. So we have negative 8 plus negative 6, which will give me a positive 2. So my final answer would just be u plus 2 squared. So let's put that in. So typing that in, I have u plus 2 squared. And that's number 17.